So I'll give you a big picture understanding of the quadratics topic. Then we'll go into the more specific thing we're going to learn today, which will be expanding. And if we get time, we'll get to some factorizing as well. Yeah, quadratic. So first of all, let's define what quadratics is. A quadratic equation or an expression is more like a generalization of linear. So think about this. What does a linear expression look like? What's the most general linear equation or expression? Or we can give you an example. What's an example of a linear expression, an equation? 2a plus x. Okay, cool. Plus 15. Okay, this is linear. But we're going to go even simpler. What if I told you to just work with one variable? What's the one variable linear equation? 2a equals 4, yeah. Or if you want an expression, you could say 2a minus 4. Like anything like this. It's linear. So what's the general form? So let's pretend, let's see, ax plus b. And here a and b aren't a variable. They're actually like values, but we're just assigning them variable. Sorry, we don't know what they are, so we've given them like a letter, but they're called parameters. They're not variables. There's only one variable, just x. And normally we're going to work with x. Of course, you'll work with other variables as well, but and yeah. Wait, give me a second. I've got a text from questions. Yeah. So this is the linear equation in general. So every single linear expression you'll see is some form of representation of this. 2a minus 4, or let's call it 2x minus 4 for the sake of this, is an expression where a is 2 and b is -4. Another example could be 7x plus 5. Could also be 11x minus 3 plus 8x. Realistically, what this is saying, if we collect all of like terms, we'll get to this form. So even the form, ones that don't look like this form, we can bring it to the form. For example, we collect 11x and we get 19x minus 3. And now it's in this form. So a quadratic is a slight generalization. Now, do you guys know what generalization is? Uh, that's like generalization, similar to that. It's more in math, generalization means we are like there's a restriction, right? Every single equation has to satisfy this form. We remove that restriction and allow for some other things to come into it as well. So, for example, very simple example would be you have a parallelogram and rectangle. You can say that parallelograms are generalizations of rectangles. Why? Because every single rectangle is a parallelogram. So we've restricted the conditions. The conditions for a parallelogram are the conditions for a rectangle are parallel sides and 90-degree angles. But for the parallelogram, we've removed one restriction, which is the angle restriction. The sides are still parallel, but the angles don't have to be 90 degrees. So we've made it less strict on the rules. That's the generalization. Does that make sense? So that what that means is every single linear equation is also a quadratic, but quadratics allow for something else to come in. And normally speaking, generalizations are a bit more complicated because we have less rules. It's harder to they become more complex. And essentially, what we're doing is we're going to add an x squared term. We're gonna say, all right, in the linear we allowed for constants and this linear term, which is like x multiplied by something. But now we're gonna allow x squared in it. So you can have x squared plus 7x plus 5. That's a quadratic. So the linear bit, but then you also have this new x squared term. That is what a quadratic is. Now, why do we do this generalization, right? Like, we got to have a purpose. We don't just randomly generalize. And I think the simplest example to see this is with geometry. I think we may have covered it last week. Last term. We may not have. I'll show you a problem where quadratics appear, a very natural-looking question. Okay, let's say we have an area problem. Okay, we have this, and it looks like a square, but let's say it's a rectangle. We have this rectangle where one side is 7 and the other side is unknown, but we know the area is 89. If I ask you to find this side, where does it come from? 89 divided by 7. Yeah, you can do it without algebra. But if I forced you to use algebra, you already got to the answer. There's a step before that you can do to get there. So to really set up the algebra, I'm really forcing you to do this. Yep, let's call it x. What's the area formula? Exactly. You got length of 7 with this x. 7x equals area is 89. And then you get like a very simple equation, right? This is linear. So these are the linear problems, geometrically speaking. And honestly, linear problems, super easy. We don't even need to worry about it. But where it gets tricky is when we get to the nonlinear problem. Here, we had an unknown side, and everything else was known. But this problem, which might seem very simple, is actually a lot more tricky. Let's say we know the area is 52, and we know that this side, actually, we don't know either side. What we do know is AB is 2, so this is meters squared, meters longer than AD. So we don't know what both sides are, but we know how they're related to each other. Now, I mean, like, it seems like kind of similar problems, right? It's just Unknown is not a single side. It's both sides, but we know how the two sides are related. Now, how do we solve this?
So AB times with AD equals.
Yep, sure. That works.
It'll be like you have to do the I don't know, you have to somehow divide 52 equally, but A and B has to be +2.
Yeah, I'm like, that's sort of the idea we want to do, but it's hard to do that with like directly, right? Because like at the moment, this is two unknowns, and as we know from our knowledge of simultaneous, if we have two unknowns, we need how many equations? Two. So it might not be possible to solve it in its current form. But we have not used this fact at all. We can probably use this fact lots in. And the key is, well, they're related. So if this is x, or the shorter side, if AD is x, what's the longer side? If we go y, xy, x plus 2. Now we have one variable for both. And then the area problem becomes x times x plus 2 equals 52. Can you solve this? Okay.
Okay, x plus wait, 2x plus 2x plus 2x, and that is 4x.
You're close. Is x times x 2x?
X squared
X squared plus
plus
2x equals 52. And this is a quadratic. And unfortunately, it's not easy to solve. And like this problem, you can't even solve by guessing and checking. Before I gave a problem that was guessing that you could do using guessing and checking, and actually like this one, but also like last term when I did this demo, maybe it would have been for the Sunday class, might not be you guys. But when I did this demo, I gave a problem that was possible to do with guessing and checking, which was I thought 48 here, 52. And this one's very easy. Do you know why? 40 is not a square number. No, quite. It's close to that. It's the fact that the whole number answers. If x is 6, 6 times 8, 48. Right? You can guess the check to that. But for 52, that's not an answer. There's no like whole number answers that'll get you there. 7 times 9 is 63. So it's between 6 and 7. And it's not even a fraction, it's a third. So this is where we start. This is our natural geometric problem that looks pretty simple. Gives us this quadratic. And we don't know how to solve it. Right? The reason it's hard to solve, you'll see soon. So just take my word for that. Take my word on that for now. But we'll build up to that. We're going to build up to that. So maybe like in a couple of weeks' time, you'll be able to solve this. But do you see the motivation for it? They appear in these geometric problems. And actually, like the motivation for this is even more extensive than this. It's just this is the simplest problem that I can show you that uses quadratics, but quadratics are everywhere. Do you like, in physics, if you throw a ball in the air, the path the ball will follow is a parabola, which is the graph of a quadratic. So quadratics come up in physics. If you're in economics, you might have like a lot of model for profit against like, cost or whatever. Have a quadratic thing. And it might look like this. Again, quadratic graphs. I'm not expecting you to know any of this. But the point is, quadratics will have like this turning point where everything's maximized. And in like economics, you're trying to find this point because obviously companies want to maximize profit. So they have a lot of real life applications. They're just a bit more complex, but so I wanted to show you a simple application where they do show up, and we'll build up to being able to solve this. In fact, this is probably one of the harder quadratics. You can solve this in two methods, which is a thing called completing the square and what else? Completing the square and oh yeah, and just the quadratic formula. There's a formula for quadratics to learn as well. And yeah, we'll get to those later. But that's the motivation for our set out. Now I'm going to give you a quick overview of the topic. So here's how it's going to run. We're going to start with some basic skills. And they're not super, like, the reason I say they're basic is they're basic in the realm of quadratics. They're still not super easy. Maybe expansion's pretty easy, but the second basic skills are not even that basic. Then we'll learn more advanced skills. And then we'll finally get to problems, like real applications. Right? So the basic skills that I will be teaching you guys is expanding, algebraic things, also factorizing. Like expanding's pretty easy. Get to do. Factorizing. I'm sure like a lot of this is sort of prior knowledge, but then like expanding is something like this. If I give you an expression like this, I want you to use the distributive property and expand this out. X times x is x squared, x times 7 is 7x. So that's expanding. And actually, let me do the answer. X squared plus 10x plus 21. But factorizing, well, it's when I give you something of this form and I want you to get back to this. That's when it gets a bit tricky. So, for example, x squared plus 5x plus 6. And then I'm going to ask you to convert it back to expanded form. Now, who's done this before in school? Yep, good. Have you done this, Alicia? I'm just asking this because I know you guys are in year 9, so
Yeah, I have.
okay.
Sorry.
No, you're good. Right. So this might be a little bit of revision. You'll find it a bit easy. That's fine. And by the way, have you done this, Kushal? You're in year 8, so I'm not too sure.
Yeah, I have, and I'm in year 9 actually.
Oh, you're 9?
Yeah,
Oh, I'm so sorry.
it's okay. It's okay.
Well, you're only 1 year below a deep.
Yeah.
Oh, I didn't know that. Can I change my records? Got you 2 years below a deep. In that case, you've done this as well. Okay, everyone here has done this. Okay, well, we can go over this a bit faster, but we'll be learning the more advanced skills that we'll build on this. And actually, I'll be honest, the level to which I'll go through this will be a lot higher. At least the factorizing, expanding can't really move harder. When we get to the advanced skills, we've got completing the square and this other one. Let me check. All right, we're going to also learn something called Beatrice formulas, which is not something you learn in school, but it's just a more advanced version of factorizing. And then by learning these skills, we get to the application, which is like solving quadratic equations. Which we saw before, came up here. Actually, who can already like we've already learned some things to learn, like completing the square and stuff. No, okay, that's probably a bit more advanced. So we will learn it. So we're gonna go over the basics in the first couple weeks. And even though I mean like it is basic, there will be hard problems. So we'll expect extend beyond what you do in school, of course. And then once we've learned Vita's formulas, we'll go to the applications, which was quadratic equations, quadratic inequalities. This is when it gets a bit more hands-on. And that's why having a good foundation early on, where you've done all the homework, you're asking me for feedback, will be important because you're going to use all of these skills for these harder problems. And actually, one more skill I forgot, you'll learn graphing as well. Now, graphing is boring. I understand. I hated it as well. But now that I've like I the reason graphing is important is because we are naturally visual thinkers. So a lot of hard word problems which will come up will be a lot easier if we graph and visualize what the expression looks like. So graphing will come into word problems. So they just help us think of the problem more visually and help us solve it and just make sure we don't make silly mistakes and that sort of thing. So graphing is tedious, I understand, but we'll learn it as well. And it's an advanced skill because quadratic graphs aren't super easy like the straight lines you've seen. And that's like a pretty high level overview of the topic. So we're going to go back to the basics for this week, and we're just going to cover those. Okay, let me get my resources out, and we'll get started. Mm-hmm. Where are we? There we go. Okay. Okay. First things first. Now, I said quadratic equations are a hard skill, and they are, but there's some very easy quadratics we can start with. So I'm going to give you some easy quadratic equations that I want you to solve. If I say x squared equals 16, what is the answer to that?
X.
What's your answer? Cool. What about everyone else? What's your
X could equal -4.
good point. 4 is an answer, but also -4. Now, this is a very early common misconception a lot of people have. They always forget the negative. Both the positive and the negative come into play here. And so every single sort of quadratic that looks like this, like, x squared equals something, will have a plus and a minus answer. So if x squared equals, I don't know, 17, x is equal to plus or minus the square root of 17, not just 1. Cool. So that is how, why is that? Why is that?
So you
Yeah. So the negative works because when you multiply the two negatives, like you said, they cancel. So the negative should also be included. First key point, right? So I'm going to give you a slightly harder problem. The first one would be, okay, now let's practice this concept. Let's do an easy one first. X squared equals Actually, no, I'm going to give you one more in the class. What if I say this? 2x squared minus 72 equals 0. How do you solve this?
72 is 72.
Yeah. X squared equals 36. So if you add 72 to both sides, then you divide by 2. X squared equals 36.
Negatives.
6 equals plus or minus 6. Right? So why can we do this already? Right? Like this is a quadratic, but I don't need to teach you anything. You could solve this already. Why? What makes this easy?
You know, like the other values that come up in the linear equations. You have the same, I don't know, the number after the equation, like the numbers are easier because they work together.
I think you sort of there. One word you mentioned was very close when you said linear.
Yeah, because it's like you solve it how you solve a linear equation.
Exactly. It's linear. It's basically, and actually, remember when we did linear in disguise in linear equations? We probably did stuff like this. Why? Because it's linear. And what makes it linear, or sort of linear, it's not linear because there's a square, it's the fact that the x term that isn't there. Or as we know it, the coefficient of x is 0. Right? Sorry, a better way to say it is the coefficient of x is 0. So the x term is not there. And when the x term is not there, it's a linear in disguise. And we can solve it just like we do a linear equation. So that's why you can do it without like me teaching you anything. And I'm sure you could do it before your teacher taught you anything as well. None of the techniques we use, like you don't need any new techniques to solve this. When you add the x, oh, it's a different story. But simple x, all of a sudden life gets a lot trickier. Like if I say x squared plus x equals 12. How do you solve this? It's tricky. That's all I can say. Right? X squared plus x equals 12. It's tricky. So that's why. And actually, you can be, yeah, you can absolutely. But actually, guessing and checking in this case will only give you one answer. Can you guess and check an answer? You
3.
can. 3? Yep, 3, right? Absolutely. 3 squared is 9 plus 3 is 12. Or you can think about it like this: x times x plus 1 is 12. It's like the area problem now. It's like two numbers have a difference of 1 and they multiply out to 12. What are the numbers? 3 and 4. So x is 3. But what happens with guessing and checking? A lot of people go, oh, x is 3. I guess it's double. But just like the plus and minus answer here, they missed an answer. Do you know what the answer you've missed is?
-3.
Close, not -3, but it is a negative.
Negative okay. 0.
0 plus 0 is not 12.
-4.
-4. Yeah. And how did you get that? Did you just guess and check that?
Sorta, because -4 times -4 is -16. Oh no, positive 16, and then -4 is 12.
Yeah, okay. So exactly. Well done. You got there. And actually, for the simpler ones, they will learn initially. You can guess and check, technically. But a lot of the time, if you try to guess and check, you only end up getting one. But even if you're looking for both, if it's even a bit trickier than you can get a lot harder. and it's still a whole number. I'm not saying like you can't guess and check. You can, but I'm saying it just gets harder because the numbers will be more complex. So and actually, the way to solve this is actually we're going to learn a more strategic way to guess and check as well. So guessing and checking is the real strategy for this for now. So, but we'll just learn it in a more strategic way. So we'll get to that later. But then, like, if I just change a simple number, x squared plus x, and make it 11, all of a sudden, every single guessing and checking technique completely breaks down. So that's the thing with a quadratic. You don't know if the technique works well or not. And we'll, by like learning the technique, we'll like learn. Like, here's the thing: guessing and checking is an infinite game, right? If you like, you can go forever. You can check an infinite number of numbers. So it's just when you find it, you stop. But if you don't find an answer, you don't know if the technique works. That's the problem with guessing and checking. And the first technique for quadratics will limit the numbers we need to check. And second technique will be more algebraic, right? What's going to happen is we're going to try to do this first technique, which has a limited number of things we check. And if none of the answers work, then you go to the algebraic technique. So we're just refining this guessing and checking. And actually, guessing and checking will be the foundation of the first technique, but it's just a more refined guessing and checking. Okay. So anyway, that's a bit later. Well done for you though. Like that was not super easy, but we'll get to that soon. So let's practice this. So the reason this is easy to reiterate is because it's like linear. Why is it not? Okay. Right. So you can do for this. So let me give you some to practice. Okay. Let's do these two questions. And for you guys online, please submit your answer on chat.
Okay. You can simplify the code as well because set simplification technique revision is good related to the topic.
Okay, we'll go through this in a minute. Okay. Okay, let's go through this. If we have x squared minus 18 equals 6, you add 18 to both sides, you get x squared equals 24. Right? Then it's a square rooting, so x is square root or plus or minus square root of 24. Right? And simplifying for that. And actually, I'll be strict on this in the homework, so you'll be required to simplify the thing. Do you know how to do that? So the way you do it is you find any square factors here. Basically, for sets, this property doesn't exist, so you can't split it up like this. But you can split it up like this. Now, why is this good? Well, if you have a square, let's say a is a square number, right? When you get root AB, you have root A times root B, but root A is like a to square, so root A would be a whole number. So if you find a square factor here, and you factor it out and separate them, that set will become a whole number. So a square factor of 24 would be 4. So it's 4 times 6. And then you go, that's root 4 times root 6. But root 4 is just 2. So it's plus or minus 2 root 6. So if you are a bit rusty with your set simplification, that's how you do it. And you can practice that for the homework as well. Cool. What if I give you a worded problem like this? We'll get to worded problems soon. So we'll get to 5.2 now. By the way, if you find any mistakes you made, that's okay. But important thing is how you respond to those mistakes. So keep track of them. So just write down the mistake you made so that you can avoid it. Because a lot of the time, some of these mistakes are like knowledge gaps, but some of them are also habits. So it could just be a bad habit you've gotten used to. You forget to put the negative in or something like that. Just write down what the mistake was so that you can work on it for the homework. Okay, for question 2, if 3x squared minus 162 equals x squared. And here, the way we do it is, again, it's linear. And I know that you guys online can't see me, but I'm using air quotes, so it's not really linear. So it's sort of linear, as we call them linear in disguise. So with 3x squared minus 162 equals x squared. So we treat this like any other linear equation. And the way you solve linear is to isolate everything. So you will minus x squared from both sides. You bring the x squared all to the same side. So you get 2x squared minus 162 equals 0. Then I'm going to bring the constant term to the other side as well. So 2x squared equals 162. And then you go x squared equals 81. And you need to square root both sides. So x is plus or minus root 9 is my answer. Again, the square root is just 9. But we take both the positive and the negative because the negative square is also 81. So that's how you do this one. And I'm sorry, I forgot to give you feedback on the plus minus. I might have missed that. Okay. So that's how you do those questions. Now let's get to okay. We'll do a little bit of very basic factorizing for the next type of equation. And here it's the second type of equation that's simple and you don't need much to solve. So actually what we're starting with before everything else is giving you a little taste for quadratic equations with very simple equations, which is equations like this. X squared equals 2x. Equation of this form, x squared, ax squared equals bx is the general form focusing on. But we're trying to solve these types of equations. Now, any ideas as to how you guys might solve this? So before we drop the linear term, now we've dropped the constant. And both of these are simple, but in different ways. Sorry, simpler to solve. It's closer to linear, essentially.
Could you do x times x equals x plus x?
Ooh. Yep. Let's see. And what do you intend to do with this? Oh, you're trying to see the symmetry. Yeah, that is cool symmetry. They're like two x's. I'm not exactly sure if we can proceed this way. I'm trying to think. Not quite. I don't think I don't think I see a way, but that is a cool thing to spot. Um, square root both sides. Let's give that a go. We square root this side, get x. Square root this side, you get root 2x. Does this look nicer or uglier? Uglier. So I think we might not be going this direction. That's okay. Finding different ideas. Again, like when I ask you guys to give ideas, guessing is the way. And you'll probably like I haven't taught you this, so you're probably gonna miss, and that's okay because now you're not gonna try this school. That's okay. Like that's part of learning. Guessing is perfectly fine, and guessing wrong is actually perfectly fine. It's actually really good because now you have in your mind certainty that these other techniques you thought of don't work. So those two ideas aren't quite there. Like we just sort of saw with our instinct, right? Like this one's actually a cool observation, but it sort of breaks down if I give you a more complicated one, like 2x squared equals 5x. Then we're not sure exactly how we get to this form. Right? So the reason this might not work is because you can't convert something like this into this form. And well, the second method you can convert to this form, but it just looks ugly. Like we're introducing a square root that we can't reduce easily. So what can we do instead?
Can you divide both sides by x?
Cool. Yes. We divide both sides by x. What happens?
It equals to x equals to 2.
Yep, you divide x squared by x. One of the x's cancel, power laws, and 2x divided by x is 2. X equals 2. And that's our first method. Are we done there, Alicia?
I think so.
Okay, you're very close, but there's a little bit of an issue. It's very small. You're 95% there. The issue comes from you're doing something a bit risky. Dividing by x. Whenever I do division in algebra, I get a bit scared. Do you know why that is? What's the first rule of maths? You can't divide by what number? 0. You can't divide by 0. Now, x is a variable. So 0 is in the realm of possibilities for x. So whenever you divide by x, you know that you could potentially be dividing by 0. So that's actually why this is not the full answer. Another answer is x is 0. Plug it in here. Does it work? 0 squared equals 0. 2 times 0 equals 0. So it does work. But why did it not show up when you divide by x? Exactly. So the case where x is 0, you would have divided by 0, and that's impossible. And that's why weird things happen. So the rule to take away is dividing by 0 does funky things, right? So what should we do instead? Because this is a valid method. Well, the way we fix it is we go casework. The division by x works whenever x is not 0. So you do case 1. You assume x is not equal to 0. And then you divide by x. Then you get x equals 2. But then you also gotta then have the case 2 where x is 0. And you need to check if this is an answer. And that's pretty easy to check, right? How do we check that? Yep. Sub into equation. You get 0 squared equals 2 times 0, so it's valid. So x equals 0 is a solution as well. Now, this is the first method to do this. The rule I want you to take away from this, though, is the fact that what is it called? Yeah, dividing by x, any variable, is a scary thing because 0 is within the realm of possibilities. So the easiest way to treat that would be to just only do the split the cases and assume x is not 0 when you do the division. But then, because you can't make that assumption normally, you need to check the case for x equals 0 as well. When you've done these cases, x equals 0 and x is not 0, you've covered everything for x. And then you're all good. Does that make sense? That's method 1 to solve this. If this is method 1, that must mean there's another method as well, right? There's method 2 now. This one actually introduces some new ideas we're going to use later on. Method 2 is we're going to use something called null factor law. And if I gave you this equation, AB equals 0. Now ask yourself for A and B. What are the solutions for... What are some possible solutions? What's 0? A 0. Both of them could be 0. So 0, 0 is the solution. What's another solution? 0, 1. 1, 0. What else? 1, 0. Can I go like 100, 0? Yeah. Okay,
It's like infinite.
there's infinitely many solutions. But what's special about all of them?
There's zero.
Yeah, there's at least one zero. And that is the key. So what this means is either A equals 0 or B equals 0. And this is called null factor law. And null means 0, again, of course. But the reason this is special is because 0 is the only number this works for. If A times B is 0, at least one of the two must be 0. That's key. And if I say AB equals 2, is this true necessarily? You have, 1, 2, -1, -2. And these ones look fine because 2 is in all of them, or 2, 1. But then I could also have √2, √2, or -√2, -√2. Could have 3/2, and then the other one could be like 4/3. But take my words, correct? You can check if you want, but just a basic fraction multiplication. But if I have this number here not equal to 0, then I can get weird answers. But when it is 0, there's a special property, which is that at least one must be 0. And that's null factor law. Does that make sense? Because if two numbers multiply to 0, at least one of them must be 0. So that means, otherwise maths breaks, right? Think about it. If you had like two non-zero numbers that multiply to 0, let's say like in a crazy world, let's say 2 and 1 multiply to 0, that would break maths. Why? You can start with any number, and then you multiply by 2 and 1. All of a sudden, this is 0. So 3 times 0 is 0. So you could like get to 0 from like weird numbers. So null factor law doesn't work, and you're probably like laughing at what the hell is this guy talking about? Because we're so used to like idea of 0. So this works for 0 because properties of 0, like 0 is the thing that reverses, is the opposite, like additive. What's the word for it? Negation. Like add number and it's negative, it gets to 0. Sure, okay. Don't worry too much about that. But 0 is a special number, so that's why the property holds for that. So how can we use this idea for this equation? So we have x squared equals 2x. That means x squared minus 2x equals 0. Do you agree? Now this, I'm sure you agree with it, but you might be a bit confused because you're making it more complex. You have this nice equation with, these two on opposite ends, which is what we're used to because they're two different types of terms. So it's good to keep them apart with our linear algebra intuition. But we're not in linear algebra anymore, so some of the intuition will change. So you have x squared minus 2x equals 0. And what can we do here? Here, do you notice anything in common between these two terms? X, right? X is a common factor. You can factor it out. Then you get to x squared divided by x is x minus. By the way, do you guys know how to factor algebra? It's -2. Now, if it doesn't make sense to you, I'll explain it. Like, if you have 18 plus 45 and you factor out the common term of 9, 9 times what? Plus 45? It's not 4. 5. 45 divided by 9 is 5. What we're really doing is we're saying it's a common factor of This is 9 times 2 plus 9 times 5. I'm going to remove this common factor. And I remove it, I'm really dividing it to bring it outside. Dividing both by 9 and then bringing it outside. I've done the same thing here. I've divided both of these by x, but not really divide. So I factored it out. So like, I don't need to worry about like violating the division by 0 condition because like it's not technically dividing. I don't remove it. I leave it here as it is. And then I go boom. So factorizing is a way sort of you can cheat division. And then you can cheat that this property which you sorry, then you don't need to do this casework. You just sort of instead of removing it, you leave it out of it. You've really done the division, but you're not fully doing it. So that's why it's okay compared to when you fully divide by x, which can be a problem. And then here, what can we do? What law did we just talk about? Exactly. Well, both of them can be, as in like, first solution is this one 0. The second solution is this one 0. X minus 2 equals 0 means equal. X minus 2 is 0. You add 2 to both sides. I've just added 2. What do you mean?
Because they're the same term. So that if one of them equals x, like one of them equals 0, wouldn't both of them have to be 0 at the same time?
Well, no, because this one would be 0 and -2. This is x minus 2. Yeah. So the x would be 0, that's fine. But the overall term here would be -2 when x is 0. So that's my first solution. And the second solution is when I make this part 0. Does that make sense? It's saying at least one of them must be 0, so you can consider both cases. But this is 0, and then where this is 0. And then if you want, you can check the case where they're both 0, but that won't happen. Do you know why that is? Because they're the same variable here. So if they're not equal to each other. This is x minus 2. They're not, yeah. Yeah, they can't be equal to each other because of that. So here they're independent, there won't be a difference. So 0 and 0 is the same. So you won't get this case when it's the same variable. And that's how you solve these equations. Now these are relatively simple, but the thing is, you might be like, oh, let me pick a method I like and stick with it. But don't do that. Do both methods. In the homework, do both methods. Do you know why that is? If I told you to pick one, you're probably going to pick this one. A bit simpler. This idea is new, it's going to feel weird to you. But trust me, this idea is the one that's more useful later on when we get to harder quadratics. So stick with so yeah, you need to get comfortable doing this. So it's going to be uncomfortable at the start because again, it's new. So just stick with it. So do both methods. And then the logic of this will make more sense to you as well. Because this will come in handy later on. Cool. Let's do some, actually, what's the time? Let's take a break. Let's take a 5-minute breather. Then we'll come back and do some example practice. You guys covered these equations in school?
But not.
Not quadratics, okay. Oh, so you've done like the skills, like expanding, factorizing, but you didn't do the equations.
I got confused because when we did factorizing, we did the straight part, and then we ended up with like the answer that was a square number times stuff on it.
You mean like 2x squared or something?
But it was like, I don't know, it was like a factor form.
Might be different. But it's the factor form. Different to the factor form we were talking about. Is it? Yeah, I think one thing you'll take from this topic is your idea of factorizing will change. Because factorizing till now has been with all whole numbers. And that's called factorizing with common factors. But we're gonna do a lot more weird factorizing here. And that's why I said factorizing not really like a basic skill, although it is basic in the realm of quadratics. So, but anyway, we'll get to that. Like, I think after the break we'll finish this 5-10 minutes. Then we'll do a bit of time on expanding and introducing factorizing.
For the equations, the linear relationships, we're gonna have questions that were equations that were a lot easier, and then worded problems at the end, which were 10 marks each. And then there's trigonometry and indices.
Okay, so yeah, that sounds, I think stuff we've covered before. How'd you find it? Good. Yeah.
I think our next exam is like, because it's semester 1, semester 2, so we don't do those topics again.
Okay.
So I'm not sure like what our next two topics is, but I think because we got the CAS, so they're gonna make us do like some sort of graphing, which we haven't done yet, but they'll like teach us how to do it on the calculator.
Okay. And I'm pretty certain you'll probably do quadratics this semester.
Yeah.
Because year 9's when they really properly delve into quadratics, at least the start of it. So you'll see a bit. I'm sure, I'm fairly certain. At least I did in my school, but I don't know, like, because some schools have different curriculums. So you should have it next sem. And that's why this is going to come in handy. Like this topic, I guarantee you, for every single one of you, will be new, besides like some basics, right? Like expanding will be, I think everyone in this class will know expanding, because I think we did a bit of expanding even for modular arithmetic, so we've been using it a lot. But factorizing will be new. Completing the square will definitely be new. And that's why, like, I want you guys to stay on top of the homework.
I think it'd be good if I do it at school at the same time. That'd be really good.
Yeah. Or like, I mean, yeah, it'll be easier because, but in less effort, you can just chill in school. Yeah. Yeah. But if not, you can like, yeah, I think if you do the homework properly, you'll find the school super easy. I'm gonna go pretty deep in this topic. Like that's why I like my plan this entire semester. So this entire term for this.
Because that's when the exam felt good, because linear relationships is very like logical in how you answer it. And then
Yeah.
we were doing like I think modular arithmetic, and I was like, what is this? And then I just did the exam, and then it was all like basic problem solving. And then
Oh, okay.
good in my brain.
So like you were like your mind was like boggled by modular arithmetic. Then you went to exam, like, this is easy. Yeah, like I'll be honest, modular arithmetic was not easy.
It was like I've never heard of it, so then it was
Okay.
confusing as well. But
Yeah.
I was like trying to explain it to my dad, like what it was, and he didn't like. He was like, "Don't tell me." And then my mom was like, "What would you do in class?" Don't want to know. I didn't get it then. I don't think.
That's fair. I'll be honest, this topic more logical. So you might like it more. It's hard. I think it might get harder than modular arithmetic.
I like algebra.
This is like that. All the processes have a very clear logic. Yeah. The reason with modular arithmetic was some of the proofs required advanced algebra. And that's why I didn't get into the logic behind it. So you just have to trust the property. But here we build everything up. Okay, let's get started again. We will first start by giving you some problems to do on your own. So let's go through them. So for the first method, first, these are the questions. For first one, you have x squared minus 5x equals 0. Second one is 3x squared equals 8x. Final one would be a word problem. Three times my number is equal to the square of my number divided by 5. What are the possible numbers? By the way, if you can't read my handwriting, please let me know. Yep. For you guys online, please submit your answer on chat.
Because things that is clear and that you have any.
Yeah, process, sure. Has everyone got the questions written down? Can't zoom in too much on everything. This should okay. I can get this much. Is this clear enough for everyone? Okay. Is this clear for you guys online as well?
Yeah.
Yeah, cool. Okay. Now, because you just learnt it, I'm gonna give you the thing, but of course, at home, try to recall this alone first on your own. Just try to recall as much as you can, then refer to your notes. And whenever you refer to your notes, you should immediately try to do it without notes after, at home at least. We don't have time to do all of that here, but like if at home, you should be more strict with how you give yourself, how you do your homework. Second, also you're on the right track. So try afterwards. Try to do it with the other method as well. I know you're doing the harder method. That's good, but also do the division method as well, because every single method has like its own learning benefit. So knowing more is never gonna hurt. By the way, if you guys have any questions about these methods, let me know, because clarifying these doubts now will help you when you have to do the questions at home for homework. So you don't need to do both methods for all of them for now, at least, just for time's sake. So I know you can do it for one at least. That's great. We done part 3. It's a trickier one. We'll go through the answers in like 2 minutes, at least for part 1 and 2. I might give you more time for part 3. So if this is 5, let me make that a better 5.
Right, when it says what are the possible numbers, does it mean like find?
Yes. And the reason I say that is because there's multiple answers. So instead of just saying find the number, find the numbers, essentially. Find the possible numbers. Okay, let's go through both of these for part 1 and 2. I'm going to do both methods for question 2. I'm going to do just the null factor law for question 1. This question 2 is the trickier one. X squared minus 5x equals 0. If you do null factor law, if you factorize the common term, you get x out. X minus 5 is what's in here. And that means either this is 0 or the other one's 0. If x is 0, that's just the answer. If you have x minus 5 equals 0, that means x is equal to 5. That's my 2 answers. See? For the second question, null factor law is again very similar. You bring everything to one side, factor things out. And you can bring it to the other side. It won't change the answer. And then you get the same answers again. First one is x equals 0, or 2 is 3x minus 8 equals 0. If you solve this linear equation, you'll get x is 8 on 3. And that's your 2 answers. If you do this with dividing by x, you'll get 3x squared is 8x. So you divide by x on both sides, you get 3x is 8. But when you divide by x, consider the case you have to consider that it can't be 0. So that's your first case. So then you get x is 8/3 immediately, but then you got to check the case for x equals 0. And that one you just check by substitution. So 3 times 0 squared equals 8 times 0. 0 equals 0. This is correct. Therefore, x equals 0 is also a solution. And then you're done. You have your two solutions again. They are exactly the same. Any questions about that? Okay, in that case, let's discuss part 3. So for part 3, we have 3 times my number is equal to the sum of my number divided by 5. Sorry, it's equal to the square of my number divided by 5. So what you can do is you can let your number be some variable. Easiest, for simplicity, let's say it's x. You can pick n for number. Doesn't matter. It will be the same equation in the end. So 3 times my number, which is 3 times x, is equal to the square of my number divided by 5, which is like x squared over 5. And then you solve this just like you did before. It's the same type as before. Either of the techniques we talked about would work. I'm not going to go over that. I'll let you do that, figure that out on your own. But the process is the same as the previous ones. Any questions about these? No. Okay. In that case, let's move on. We've got another 15 minutes to learn some new stuff. Okay. This one, it was okay if you didn't send the answer to the ones before. Like, obviously, ideally you would. But for this one, I want everyone online to send me the answer because knowing your ability for this is so crucial to move on. I'm just going to give you a quick warm-up test to see your expanding skills because this is the foundation for all the factorizing we're going to do. So I'm assuming you guys are familiar with this, but I need to check correctly. So please send your answers to me, all of you, both of you, right? So make sure to do that. So expanding. The thing with expanding is fairly simple. It's really just the distributive property brought to algebra. And we give it a new name called expanding. Now, what's the distributive property? It's in multiplication, when you can have multiplication of two numbers. Obviously, this is pointless because you can add 3 and 5 together. But what you can do is you can also do the multiplication like this. 2 times 3 plus 2 times 5. So what you're doing, you're distributing the multiplication to every number inside the bracket. That's why it's called the distributive property. And this also works for when there's two brackets, two things in both brackets. Again, bear with me, this is pointless because you would add the numbers normally, but for the sake of showing the property, you can also do 1 times 3 and 1 times 7, and then 5 times 3 and 5 times 7. And that will get you 1 times 3 plus 1 times 7 plus 5 times 3 plus 5 times 7, right? And that's where you're distributing each number with every other number in the brackets. Sorry, every number in the other bracket. And then if you check, we'll check if the answer makes sense. 3 plus 7, 5 times 3 is 15. 5 times 7 is 35. 10, 15 plus 35 is 50 is 60. Okay, so it's 60. And if I do this directly, 1 plus 5 is 6. 3 plus 7 is 10. Obviously correct. But this is verification that this factorizing method still also gives the same answer as what you would get directly. So this is kind of boring here, it's pointless. But where it gets interesting is with algebra. And that's why we even mentioned the distributive property to begin with, because it gets more useful when we get to algebra. So if we apply the exact same thing to algebra, the results aren't so trivial. Right? Let's do this question. Distribute this. Expand this out by using the distributive property. Wait, who has questions about the expansion, like applying the distributive property? Okay, seems like you guys are comfortable, but you please be honest. I'm happy to slow down here because this is probably the first key point. The first two were sort of like a gentle introduction. Now this is the first very broad concept. At least we're going to build up to the first broad concept. You finish that. Consider these extra questions. Part A. Part B, Part C. This is maybe a law we learned a bit early today. Might be helpful. You tried expanding it out, right? Actually, I can see why we tried that because we just did expansion. But think about it a bit earlier. There's law we learned that we can use, like before the break. Okay, so part A, the expansion. And actually, part B and C will justify why we care about this expansion in the first place. Or maybe the opposite of the expansion. So if we expand this out, x plus 3 times x plus 5, x, you use the distributive property, multiply x by every other term, for every term in the other bracket, same with 3. Times x is x squared, x times 5 is 5x, 3 times x is 3x, 3 times 5 is this. X squared plus 8x plus 15. And that's your answer, x squared plus 8x plus 15. Now when we get to B, right, and that's expansion. Any questions about that? That's a basic thing you probably got to learn. All right, cool. Well done, Kushal. That looks good. Yeah, so for part B is how we're going to justify this, why we care about doing this expansion. Well, actually, we'll learn that expansion is not the one we want. We want to go backwards, which is, well, what we're going to motivate factorizing. But x plus 3 times x plus 5 equals 0. How do you solve that? Any ideas? Now, I can see like I might have led you on might lead you onto a wrong track because we just did expansion for this. So you might try x squared plus 8x plus 15 equals 0 by doing the expansion. That's just part C. And actually, this is hard. This is harder in this form compared to this form. So forms actually there's something else is in this form. So the idea is not expansion, and if you tried it, that's all good. Now you know do not try that in the future. It's a good experience actually for that. But we just learned about a law before, which is the null factor law, which says that if two numbers multiply to 0, at least one of them is 0. So that means these two multiply to 0, that means this is 0 or this is 0. Or both, but both is not possible because you can't have x plus 3 and x plus 5 both equal to 0 at the same time. So you won't get an answer for both. So instead, what you do is just go x plus 3 is 0, first answer. 2x plus 5 is 0. Of these, x equals negative 3, and then you're done. Any questions with this? Okay. There's null factor law that comes into here. What about the part C? X squared plus 8x plus 15 equals 0.
That's what I got. And I expanded it before, and then I tried to do continue it and do it.
Yeah.
So
That's right. That's a good observation. Very good observation. What does that tell you about the answers?
that more to it.
Why is it more than 0?
Less.
Oh, I see. Because they're all positive. So you might have negative. You must need negative numbers too.
Yeah.
That's a pretty good observation. Actually, that's correct. But it doesn't really help us get the answer exactly. But it is a very good observation. The key here is this. You know how you said when you expanded x plus 3 times x plus 5, you got to this? That means they're equal expressions. That means x squared plus 8x plus 15 is also the same as this. It's just a different way to show the same thing, right? If you expand, you're still keeping everything equal. And we've just done the reverse, just like opposite, undone the expansion. And then when you do that, you get this, and all of a sudden, same process as before applies, and you get the same answers. Now, that is the general process. There is no magical way to solve quadratics that look like this, unfortunately. You have to get it to a different form. First form we're going to learn about is the factorized form, because then you can do null factor law. You'll learn other forms later, but the other form is actually going to come back to like this method, like the first type of equation. Basically, like, do you remember the two types of equation, the linear one and then equation type 2 as I named it? What you've really done is converted this into a type 2 equation, which is a factorized one. The harder one is to get to the type 1, and we'll get to that later. But the first thing is we're going to get practice with this. So I'm going to leave you at that. But that's still not easy because I didn't tell you how to get there organically. You only got there because you observed that from part A after doing the expansion. The tricky part we're going to touch on next week will be, how do I just look at this and figure out what this factored form looks like? And that, keep that thought in the back of your mind, and if you can, Google that stuff in your spare time, but because we will cover that next week. How to get the organic, right? We didn't get the organically. Do you know what I mean by organically? Like, we just observed that because we did part 1A. But next week, you're just going to look at this and know that when you factor it out, you'll get this. Does that make sense? We're trying to get there. Because then we can use null factor law. Right? And that's it for this week. Do you guys have any questions? No? All right. In that case, I'll see you guys next week. I'll upload the homework questions straight after, but make sure for this week to submit your homework so that I can give you feedback on it. And then I can correct your misconceptions, because you probably will have them at some point. You might not have them this week. This week is a little bit easier, but you might have them this week. But I'll guarantee you'll have at least one misconception as you go along, because it is a hard topic. And actually, it's far more efficient to make mistakes, have misconceptions, and correct them, than to try to get everything perfectly right. Right? So just do it and get feedback and adjust your understanding based on the feedback. Make sure to do that. I will be strict on it this time. Okay. Other than that, hope you guys have a good one. I'll see you next week. Bye.